When we were designing the next generation instruments, the Quest and the Venture, we're trying to put ourselves in the frame of mind of the customer. What is best for the customer?
And so water cooling, I guess, was one of the remaining problems. If you've got water, there are going to be problems eventually, leaks or algae or whatever. I've been amazed at how important this is to customers to have a system that neither needs water cooling for the source nor needs water cooling for the detector.
So you need to do two things. You need to lower the power dissipation as much as you can, and then you have to very carefully design all the cooling systems. The system has to be designed to exacting tolerances and has to be manufactured to exacting tolerances.
Customers have been really excited about air-cooled systems just from the idea of the lower power consumption. Both the CMOS has much lower power consumption of CCD sensor, and with the air-cooled source, it's just more green.
This is huge. Hugely important. You've got whole green campuses.
There's no real difference in performance between a traditional liquid-cooled system and a new air-cooled system. The only difference is really in the cost of maintenance of the instrument itself.
If we're talking about uptime, if we're talking about reliability, what's one of the most common failures in any crystallographic system, and I might say in any laboratory system? The water pumps, because they're a moving component. Moving components are the components that will tend to fail first. Uptime, uptime, uptime is what we wanted to achieve, and getting rid of the water is key to that.
From the point of a user, the labs are much quieter. All of those things generated noise. So if you worked in a laboratory with rotating anodes or X-ray sources with chillers and so forth, it could be very noisy to work in.
But the all air-cooled systems, they're very quiet and very easy to have them in a lab where other people are doing other experiments.
I've been astonished at the number of people who have difficulty getting water routed into their laboratories. I mean, there's whole buildings where it's just plain difficult to have water cooling on the system.
For all of our previous instruments, they might have to spend as much as $100,000 just equipping the lab with cooling water, high voltage electricity, just to put the instrument in. The new instruments need no additional cooling water, no high voltage electricity. They can just wheel a new instrument into somebody's former office, plug it in, and within half an hour they can be up and running and collecting data. On our top-of-the-line instrument, we can have a system with two sources, one molybdenum and one copper, both microsources, as well as the Photon 100, and none of these components require any cooling water.
The fact that we have almost 300 air-cooled sources in the field now, running with very, very high reliability, speaks to the fact that we've been able to do that successfully. We did that not because it was easy for us, we did it for the benefit of the customer.